This is going to be a sticky problem. The limit as x approaches 2 of this quadratic x squared is equal to 4. Okay, let's start this and see where we go. For this problem, we have a is equal to 2, f of x is x squared, and the limit L is equal to 4. Thus, we're seeking the distance delta such that for every positive epsilon, 0 less than x minus 2 absolute value less than delta produces the absolute value of x squared minus 4 less than epsilon. All right, to prove this, we're going to make an assumption like we've been doing. Assume that 0 less than absolute value of x minus 2 less than delta, and then show the absolute value of x squared minus the limit 4 is less than epsilon. Step 1, we're going to relate the absolute value of f of x minus L and absolute value of x minus a, and that's going to help us find appropriate delta. Well, the absolute value of f of x minus L is equal to the absolute value of x squared minus 4 in this case, which factors as the absolute value of x plus 2 times the absolute value of x minus 2. That's our equation 1. We'll come back to it. But we have a problem. We are stuck with an unwanted factored absolute value of x plus 2. If we could get rid of it, we could continue like we did before because we know the absolute value of x minus 2 is smaller than delta. We have that restriction on x minus 2. So we have to think about what to do for this extra factor of absolute value of x plus 2. Okay, let's bound this unwanted factor absolute value of x plus 2 with a positive number c. In other words, we're going to find a positive value c such that we have a symmetric interval around this x plus 2, negative c less than x plus 2 less than c. To do this, we're going to take an excursion. We're going to take a little jungle cruise in a hunt to find this value c. Now, we made an assumption that 0 is less than absolute value of x minus 2 less than delta. Now, delta can be very, very small, so a little tiny interval it needs to work with. So this demands that the absolute value of x minus 2, the distance between x and 2, be very small. Okay, let's be safe and assume that that distance is, say, smaller than 1. Thus, the absolute value of x minus 2 is less than 1. That's a safe assumption because it's going to be small, that distance. Now that we've established this restriction on the absolute value of x minus 2, we're going to manipulate it to express our unwanted factor x plus 2 absolute value. Remember what we're doing. We're manipulating the absolute value of x minus 2 less than 1 in order to get x plus 2 absolute value. So start with the absolute value of x minus 2 is less than 1. By definition, that's equal to negative 1 less than x minus 2, not plus 2, less than 1. And then we're going to add 4 to all three regions of this inequality because we're trying to get x plus 2 in the middle. Remember, that's what we're going for, x plus 2. That gives us a 3 less than x plus 2 less than 5 when we add these 4s. Okay, but the 3 less than x plus 2 less than 5 is not a symmetric interval. So let's contain it within a larger symmetric interval. To encompass all of that interval between 3 and 5, we'll say negative 5 on the left, positive 5 on the right. That'll do it because the smaller interval that we arrived at is contained within negative 5 less than x plus 2 less than 5. See, the reason we want to express it in a symmetric fashion is so that we can say that this implies, by definition of absolute value, that the absolute value of the stuff in the middle, x plus 2, is less than positive 5. Let's put a little star here because we'll refer back to this restriction. That ends our excursion.